Welcome to the BioCyc Metabolites webinar, which will tell you how to search for metabolites in BioCyc and how to interpret BioCyc metabolite pages. Let's begin with a quick search on the compound L-arginine in EcoCyc. You can see that that phrase matches a number of different object types, but let's move to the compounds section. Quite a few compounds contain that name in their string. Let's now click on the one that we want, which is simply L-arginine. We're now on the compound page for L-arginine, and the page tells us what database we're in and the primary name for the metabolite, and it lists synonyms. We include as many as we can so different people can find the compound by as many names as possible. The classification section lists the ontology classes under which the compound is classified. If we click on those classes, we'll see other compounds in the same class. And this component of section tells us that arginine is a ligand for several E. coli proteins. We next see the chemical structure, chemical formula, molecular weight, and monoisotopic molecular weight. The page also contains two textual encodings of the chemical structure, the SMILE string and the INCHI string. We do provide pKa values and calculated Gibbs free energy of formation for some metabolites, and the majority of these are calculated values. We have unification links that link to this same metabolite in other web accessible databases. They unify these occurrences of the same metabolite. The next section of the page shows reactions that act on this metabolite, organized by their directionality. That is, here we're starting with reactions known to produce the compounds, and here reactions known to consume the compound. Note that some of these reactions are generic reactions, meaning they act on general compound classes that contain this metabolite. Like these are all generic reactions, because L-arginine itself is not explicitly stated. As we move down, we will see enzymes that are inhibited by this compound, growth media containing the compound, which are all clickable, and transcription units that are regulated by proteins that bind to this compound. Now, commands that operate on compounds are present in the right sidebar menu. Let's expand it. Let's try the command show this compound in BioCyc down here. We might want to view a compound in the BioCyc database to see the larger set of reactions and pathways that operate on this compound across all domains of life. You can see the reaction and pathway lists are much longer than in the E. coli database. Back to the metabolite page, the command search compounds will let us do a wider set of metabolite searches than a simple quick search. For example, we can search for metabolites by entering one or more monoisotopic molecular weights and a tolerance value that provides a little leeway in the search. Now note here, by the way, that our default database has changed to BioCyc, but that's okay. I'm going to paste in 2 monoisotopic molecular weights, and we will submit our search. And the results show 2 sets of compounds, those that match the first molecular weight and those that match the second. Many of these are isomers of one another. They all have the same chemical formula, of course. And we can click on any of these compounds to go to the compound page, and we can sort by any of these columns by clicking the little triangles. Now if we go back, we can explore some of the other searches available. Another type of search that we can perform is a search by chemical formula. Now we can do either a partial match or an exact match. Exact match means the compound we match has to have exactly the same formula. The partial match says it has to contain exactly the elements that we specified, but may contain additional elements as well. So for example, C12 will return all compounds that have exactly 12 carbons and perhaps other elements. And here's our result, 428 results. We can also do a chemical substructure search. For example, if we enter this string, this SMILE string will match a chain of 6 single bonded carbons that ends with a double bond to an oxygen. Let's submit that query. And we get 3,500 results in BioCyc. And I want to close by noting that we can combine these queries. So for example, we could combine the SMILES and the chemical formula filters by specifying both the SMILE string and a chemical formula, and any matched compounds have to satisfy both of those filters simultaneously.